The idea of the Big Bang creating the universe is fascinating. That's what Einstein's theory suggests, and it's standard cosmology. However, current understanding suggests there was a phase before the Big Bang. If you define the Big Bang as the hot, dense phase from which the universe emerged 13.8 billion years ago, that phase is called inflation. So, what we think happened is that before that, the universe was accelerating exponentially fast. It means it was doubling and doubling and doubling in size, and the numbers are ridiculous. We think that if you started with a universe that was smaller than a single atom, then it would be bigger by a long way than the whole observable universe. 350 billion galaxies, in less than a millionths of a second. So, a very rapid, exponentially fast expansion. When that stopped, all the energy that was driving that expansion got dumped into space. It heated it up, and it produced the particles of matter out of which we are made and all the things that we see out there in the sky. And that's what we see as the Big Bang. Although it sounds incredible, this is the current standard model in cosmology. The big questions now are, what started inflation? What stopped it? How long did it last? The truth is, we don't know yet. In the beginning, there existed an infinitely dense, tiny ball of matter that began expanding, eventually giving rise to the atoms, molecules, stars, and galaxies we observe today. But what existed before the Big Bang? What was the state of the universe preceding it? Well, everything. The universe experienced a breathtaking cosmic expansion, doubling in size at least 80 times in a fraction of a second. This rapid inflation, driven by a mysterious energy pervading empty space itself, left the universe desolate and cold. Only afterward did the hot, dense conditions of the Big Bang emerge. Some theories propose that inflation does not cease all at once but stops in patches. Each cessation potentially spawns a new universe. These theories, known as eternal inflation theories, suggest that beyond our observable universe, there could exist many universes, perhaps an infinite number, continuously being generated. So, what does this imply? This is the realm of our current modern cosmology. If cosmic inflation accurately describes events before the Big Bang, it might push the ultimate question of our origin beyond the realm of scientific inquiry. Yet, this only extends the query further because we remain ignorant about what preceded inflation, with doubts about whether we will ever attain such knowledge. Presently, there are theories suggesting, as previously mentioned, the existence of multiple universes, potentially countless in number. It's a staggering concept, isn't it? Additionally, it's worth noting that if these theories hold true, some propose that what we regard as the constants of nature, such as gravity's strength, the speed of light, and particle masses, could vary from one universe to another. This raises the question, why does our universe exhibit conditions so conducive to life? Why do stars produce elements like carbon and oxygen, essential for life's existence? Why is everything intricately balanced to support living organisms? In such scenarios, the reason why we inhabit a universe conducive to our existence is simply because every possible configuration of natural laws exists across different universes. It's inevitable that we find ourselves in a universe that allows for our existence, as we couldn't exist in one that didn't. One might wonder about the likelihood of this occurrence. If there are an infinite number of universes, the answer is that every conceivable type of universe exists. I want to emphasize that this is highly speculative territory. However, the notion of inflation, the concept of rapid exponential expansion preceding the Big Bang, is not speculative but rather a cornerstone of mainstream cosmology. The idea that this could give rise to multiple universes is more speculative but still scientifically plausible, with ongoing research dedicated to exploring these possibilities. This remains an active area of scientific investigation. Inflation suggests that, before the Big Bang, the universe was extremely cold and devoid of anything except empty space. This empty space contained energy that stretched the universe to its immense size and set the stage for the initial conditions preceding the Big Bang. However, there are alternative theories to cosmological inflation that delve into what triggered these initial conditions leading to the Big Bang. One such theory proposes the existence of additional dimensions within the universe. Imagine our universe as a sheet of paper, and alongside it float other universes in a larger multiverse with more spatial dimensions. In this scenario, you might wonder, what happens when these universes collide? One theory posits that the Big Bang was caused by the collision of two of these sheets, or branes, as they're called. When these branes collide and then separate, they heat up, resulting in an event resembling a Big Bang within that particular sheet of space and time. So, this presents yet another theory for events preceding the Big Bang: the collision of branes giving rise to Big Bangs and multiverse theories. While these ideas may seem highly speculative and disconnected from reality, they are grounded in mathematical reasoning. Furthermore, theories describing the universe's very early stages receive experimental validation. What's fascinating is that we are actively conducting measurements today. The experimental foundation for these theories rests on something known as the cosmic microwave background radiation, CMB. By observing the oldest light in the universe, emitted around 380,000 years after the Big Bang when the universe cooled enough for atoms to form, we gain insights into its early transparency. This light has traversed the cosmos since its release. Currently, the European satellite Planck is capturing detailed images of this light, akin to a baby scan of the universe's earliest days. These images reveal different structures and properties of the universe's infancy, providing crucial clues about the origins of time and the universe's inception. This is where these theories find their empirical support. The foundation of modern physics rests upon Einstein's general relativity and quantum theory. To unravel the emergence of the Big Bang and what preceded it, it's crucial to unify these two pillars. Only with such a unified theory can we hope to address cosmology's fundamental questions. What is space? What is time? What is the universe? And where did it originate? The most remote objects in the universe lie 47 billion light-years away, making the observable universe span 94 billion light-years in diameter. You might wonder how this can exceed the time it takes light to travel over the universe's age. The answer lies in the universe's expansion over time, causing distant objects to be farther away from us than their light travel distance. Most scientists believe the universe extends far beyond what is observable. Is there anything beyond the entirety of the universe? It's unlikely. There's a strong suspicion that our universe may be infinite in size even now. The observable part of our universe, which we've had 13.8 billion years to observe, extends far beyond what we can directly see. Why do we think this? The curvature of the universe and its structure, as measured, suggests there's much more beyond our visible horizon. The exact extent remains a mystery. It could potentially be infinite. Considering the latest discoveries and measurements in physics, we've sought answers to questions about what existed before the Big Bang, the size of our observable universe, and what lies beyond our immediate view. But amidst pondering the origin of everything, an important question naturally arises. How will the universe ultimately end? The current leading hypothesis is that the universe will expand indefinitely. This conclusion stems from the observation that the universe's expansion is accelerating, a profound mystery in itself. Previously, it was assumed that gravity's attractive force would gradually slow down the expansion, possibly leading to a contraction. There was even speculation about whether there's enough matter to halt and reverse the expansion entirely. However, the discovery of accelerating expansion suggests that unless new and currently unknown physics comes into play, the universe will continue to expand indefinitely. Thank you for watching. Did you enjoy this video? If so, please support us by subscribing, ringing the bell and enabling notifications so you never miss out on content like this.